once more, TK. And then we can start with past paper questions directly. And remember, there's lots of other stuff like empirical formula and yield and other things. TK will do every subtopic, and then we'll do a bit more over here. I'll explain everything. Now, this one is you've got ammonium phosphate reacting with what? With NaOH. Everything should be on your fingertips. What's ammonium phosphate? Ammonium is NH4 plus 1. PO4 is 3 minus. So it's going to be ammonium, NH4 thrice, and PO4. It's reacting with NaOH. Whenever ammonium salts react, they produce a salt, a water molecule, and an NH3 molecule. Ammonia gas is produced. Okay, this was one of the reactions that we did. The salt that's going to be produced in this particular case is going to be Na and PO4. And that's going to give you Na is plus 1, PO4 is 3 minus. So that would give you Na3, PO4. Need to learn how to balance this equation. There's 3 Na, 3 sodiums over here. So there's going to be 3 NaOH molecules on this side. That leaves you with the 3 N's over here. So there should be 3 NH3s. And what else? The oxens, they're 4 and 3, that's 7. So there's 4 and there should be 3 oxens over here. So that would be 3. As anyways, this equation is now balanced. And I told you that 30 grams of ammonium phosphate reacts. So we're going to do this 30 grams, find the moles. You can remember the whole question about moles is you find the moles of one thing, you'll be able to find the moles of the rest of all the substances by just using ratios. The rest is just formulas, TK. So what's moles mass divided by MR? It's going to be 30 divided by, find the MR of ammonium phosphate. What do you get? This is P is 31, 16 into 4 is 64, that's 95, 95 plus 18 into 3. What's 95 plus 14 plus 8 is 1, so that's 4, 18 into 3. Can anyone quickly do this? What do you get for this? That's the MR of this thing. Quickly, keep your calculators with you. What do you get?
0.201.
So you're going to get 0.201 moles. And remember, focus on speed. Try and do the things very, very quickly. That's very important. So the thing is, you find the moles of one thing, you'll be able to find the moles of everything in the equation. So what are the moles of NaOH? It's going to be 0.201 mole divided by 1 into 3. So that would be 0.603.
Yes.
So you get these many moles for this. This would be 0.201 moles as well. And this one over here would be what, 0.603. And this one over here would be 0.603 moles as well, I think. Okay, so by just finding the moles of one substance, you should be able to find the moles of all the other substances. Anyways, they were asking you to find this was wrong actually in the question, because they already gave you the concentration. I was actually asking for the volume of NaOH. So what you can do is you can you're given the concentration of NaOH, about NaOH, you're given the concentration. So you can use the concentration formula, which is moles is concentration times volume. So you're trying to find volume, so it's going to be moles divided by concentration. Moles you already have, 0.603, and divide that by the concentration, which is 0.15. So how much volume do you get for this? What are you getting for this?
4.02.
So you're getting 4.02 decimeter cube. What else were they looking for? They're looking for the mass of salt. So moles is mass divided by MR. So mass would be moles multiplied by the MR, which in this case is 95 plus 69, 23 into 3. What do you get? 158? I mean, what's the MR? 23 times 3, 31 plus 16 into 4. So 95 plus 69, that's not 158 actually. क्या बनता है? What's the MR?
164.
You're getting 164. What's the mass that you're getting over here? The mass that you're getting. Just once.
32.964.
32 point?
32.964.
Okay, just 1 second. $32.96?
4.
4 grams. And the next thing is, okay, just a second. So you're getting 32.964 grams. And what else are you looking? You're looking for the volume of NH3. So that's if it's RTP, TK, so you can quickly find that. You have the moles. The moles is volume of gas divided by 24 dm cube. You multiply by 24 dm cube, you'll find, so it's going to be 0.603. Multiply that by 24 dm cube, and you'll find the volume. So what do you get for that?
14.472.
Okay, so you're getting 14.472. So the thing is, you find the moles of one thing, you'll find the moles of every other thing. One other very simple concept that I need to add to this is limiting and excess. Just 1 second. We didn't do this. Limiting excess. We didn't do this. So one other, before moving on to the past paper questions, one other simple thing that I need to add is the limiting and excess reactants. Okay, that needs to be added to this. So I'm just going to add this concept directly to what we were doing, what we were up to. Now, in this case, what happens is that sometimes when you're doing a reaction, I mean, this is like a cooking recipe. You're trying to make something like NaOH and HCl are reacting together to form NaCl and H2O. Now, the equation clearly states in this case that it's 1 NaOH reacting with 1 HCl. Okay, so the ratio is exactly 1:1. What happens is that if I add 0.58 moles of NaOH, then on the other side, there should be exactly 0.58 moles of HCl that would be needed to react with it. Okay, because the ratio is exactly 1:1. But that is not always going to be the case. Sometimes, like you go in the lab, you add some NaOH, you add some HCl. Let's say you add 0.21 moles of NaOH and you add 0.78 moles of HCl. So can anyone tell me which one has been added in excess? I mean, more than the required amount. Which one of the two will not react fully? Anyway,
HCl.
okay, so it's going to be HCl, obviously, because 0.21 can only react with, according to the ratio, which is 1:1, only 0.21 moles will react. So that means you just added too much of it. You just wasted it. Because that wasn't the right quantity to add. You were supposed to add 0.21 moles, but you added just too much of it. So that's the quantity that's in excess. Okay, and this is the other one that's fully reacting. That's known as your limiting reactant, or L.R. That's your limiting reactant. So the whole concept is sometimes you'll add wrong quantities of reactants. You'll add too much of it or too little of something. So especially when you add too much of it, 0.21 and 0.78, you figured out that 0.78 was not needed. Only 0.21 was needed. So the rest is going to get wasted. It's not going to take part in the reaction. It's not going to be reacting. So the rule is that excess reactant moles are never used. I mean, in all your calculation, whatever you have to do, you're just never going to use point.
Sir, I'm sorry, but I can't hear you. Sir?
Can you hear me now?
Yes, sir.
अच्छा लेकिन वो my voice won't be very clear. And can you hear me now?
Yes, sir.
I think there's something. Just a second. So yeah, average. So can
You all hear me now?
Yes, sir. Perfect.
Logic, ठीक है. So hopefully doesn't happen again. So I don't know where you lost connection, but I was saying that the point is of limiting an excess that you just don't use excess reactant moles. Okay, they're just cut out. They're not used in your calculation. All calculations are done using the limiting reactant moles. Only limiting reactant moles are used. So for example, if I want to find the moles of NaCl, I'm not going to use 0.78. That's not going to be used anywhere. I'm going to use 0.21 moles. It's 1:1, so this would be 0.21 moles. And this other one would also be 0.21 moles. Okay, that's what we're going to do. So I mean, the whole idea is the concept clear, and then we can move on. We can sort of build on this concept. Is this clear? Yes or no?
Yes.
So now the whole problem comes trying to figure out which one is the limiting reactant and which one is the excess reactant. So for example, if I have this reaction, like I've got calcium, 3 calciums reacting with phosphoric acid molecule, and they are producing calcium phosphate, CH3PO4 twice, plus 3 water molecules. So you've got these 3 water molecules as well. So we've got this reaction going on. I'm going to add 2 random moles. Let's say I go to the lab, I pick 0.6 moles of calcium, and I pick 0.5 moles of phosphoric acid. Can you tell me which one is the wrong quantity? Which one has been added more than the required amount or in excess? calcium or phosphoric acid? Just make a random guess first. Any random. Okay, so I've gone to the lab. I've picked calcium and I've picked phosphoric acid. A certain amount of phosphoric acid, a certain amount of calcium, and mix them together. One of these values cannot fully react. I mean, one of them has been added in excess. And the ratio in this case is 3:1. 3 calciums react with 1 phosphoric acid molecule. So what I'm going to do is, can you try and figure out, according to the ratio, if I have 0.6 moles of calcium, how much phosphoric acid do I need for the reaction? It's going to be, according to the ratio, 3:1. 0.6 divided by 3 into 1. What do you get? How many moles do you get for over here? Like, let's say this 0.5 quantity is not there at the moment. Like, what is the amount of phosphoric acid that is needed to react with 0.6 moles of calcium?
0.2.
0.2.
Okay, so that comes out to be 0.2 moles. So that means you just need 0.2 moles needed. That's it. So that clearly shows that 0.5 moles were never required. They were never required. That's in excess. I mean, you never needed 0.5. That was the wrong quantity that you added. So out of that 0.5, only 0.2 will react because 0.6 will react with 0.2. So the other 0.3 will get wasted. So this is the wrong quantity. So all the moles that I'm going to calculate them using the limiting reactant moles, this one. I'm going to use 0.6. That's the correct value. This one is the wrong value. So remember also this fact that it's not always that the bigger value is the one that's in excess. You have to, according to the ratio, you have to figure out or find out the moles which are added more than the required amount. I mean, the required amount was 0.2 moles, but you added 0.5, which is in excess. So this is the quantity that's in excess. So if I want to find the moles of calcium phosphate, I'm going to use this one, 0.6 moles, 3:1. So this would be 0.2 moles as well. If I want to find the moles of water, it's 3:3, which is exactly the same. So 0.6 ratio, 0.6. So all my calculations would be done using the limiting reactant moles. The other ones I'm going to cut out. I'm just not going to touch them. I'm not going to use them anywhere because that's the wrong quantity that has been added. Is this clear as well?
Yes, sir.
Okay, everyone else, is this clear? Reid, Oswa, Mahad, is this clear?
Yes, sir.
Yes, sir.
So now there's a big problem, and the problem is that it kind of gets confusing. Like, you're given 2 random quantities and you have to figure out which one is in excess. And you just have to cut out the excess one. Okay, that's what the goal is. But there's a very easy shortcut, and that shortcut is, for example, you've got this reaction, P2 and O2 are reacting together to form P4O10. And there are 5 of them, and there's 2P2. So the ratio is 2:5. So I've got 0.15 moles of this, and I've got 0.40 moles of this. The ratio is 2:5. Now it kind of gets confusing, like when the ratios are not 1:1. In 1:1, it was pretty obvious. I mean, 1:1 was easy. You can clearly spot which one is in excess. Like 0.21 would react with 0.21. You don't need 0.78. So that was kind of easy. The whole trouble is this one. When the ratios are weird, when the ratios are like 2:5, can't really, by just looking at it, you can't really figure out which one is in excess. I mean, if I want to find the moles of P4O10, should I use this one or should I use this one? That's the whole question. And the shortcut is, there's a pretty easy shortcut, and that is, and remember, the shortcut doesn't really make sense. It just tells you directly which one is in excess. The shortcut is, you take 0.4 moles and divide it by its ratio, which is 5 in this case. Remember, it's a meaningless thing that you're going to do. You take 0.15 moles and divide it by its ratio. P2 is 2, so you divide it by its ratio. Find out which of the numbers is bigger. What's 0.4 divided by 5? What do you get for this one?
0.08.
You get 0.08. What do you get for this other one?
Yeah.
0.15 divided by 2.
0.075.
0.075.
So you're getting 0.075. So the sim. Okay, so you're getting 0.075. So the easy way is, after doing this, whichever is the bigger value, 0.08 I think is the bigger value. That's the one that's in excess. Don't use that moles. That's it. Okay. So you don't have to go into a lot of detail about ratios. Like if I want to find P4 over 10 moles, I'm going to use these, not these. The larger number, the bigger number, that's the one that's in excess. I mean, after doing this. So all you have to do is, I'm going to do the same thing over here. For example, we already did this. So I'm going to do the whole question again without thinking too much about limiting in excess. So I think we had 0.6 moles of this. And we had 0.5 moles of this. All I have to do is take 0.6, divide it by its ratio, which is 3. Okay, you can see 3 over here. Take 0.5, divide it by its ratio. So 0.5 divide by 1. Which one is the bigger number? I think this is the bigger number. That's the one that's in excess. Don't use that. That's it. Calcium phosphate, you're going to use these moles, 0.6. So this would come out to be, according to the ratio, 0.2 moles, and this one would come out to be 0.6 moles. So is the idea clear? The simple shortcut that of finding out which one is in excess. Is that clear?
Yes.
सर इसको रिपीट कर दें सर.
ठीक है, वो मैं करूँ कि I'll do another question. ठीक है, just 1 second. So let's say I've got Mg reacting with HCl, right? And it's forming MgCl2 plus H2 gas. So the thing is, I've been given, the ratio is 1:2. I go to the lab, I have 0.25 moles of this thing. And I have 0.40 moles of this one. One of the two is the incorrect value, okay, which is not the required amount. And I need to find out which one is in excess. So what I'm going to do is, I'm going to take 0.25, divide it by its ratio, which is 1. I'm going to take 0.4, and I'm going to take 0.4 and divide it by its ratio, which is 2 over here. So 0.4 divided by 2. So for this one, I get 0.25. For this one, I get 0.2. So which one is coming out to be the bigger value? It's this one, right? So that means this is the value that's in excess. That's more than the required amount. That's the whole concept. Like, you can easily spot. Kaise question pucha tha? By just doing this, take the moles divided by its ratio, take the moles divided by its ratio. If one of the value comes out to be bigger, that's the one that's in excess. And you can also check whether it's in excess. According to the ratio 2:1, 0.4 need how much Mg if 0.4 were to react fully? 2:1, so 0.4 would need 0.2 moles. So 0.25 is clearly more than the required amount. That's the wrong quantity that you added. It's not going to react in the reaction. Only 0.2 are going to take part in the reaction. So is this clear, this point?
Yes, sir. Thank you, sir.
Okay. So the thing is, there's a simple shortcut, and you'll just figure out which of the values is in excess. Because the whole problem is, if you want to find the moles of MgCl2, the whole problem is, do you use 0.4 moles or do you use 0.25? You're not going to use 0.25. You're going to use 0.4 moles. These are the moles that you're going to use. So according to the ratio 2:1, MgCl2 would be 0.2 moles. and H2 is going to be the same as well. Okay, yeah, I'm going to do another one. Try and quickly tell me which one out of the two is going to be in excess. It's I've got 0.5 moles of this, and I've got 2 moles of this. Now I want to find AlCl3 moles and H2 moles. So which one out of the two should I use? Which one is in excess? Quickly tell me which one out of the two is in excess.
Aluminium oxide, Al2O3.
Okay, because this is 0.5 divided by 1. Okay. Just remember this thing. I mean, this thing has no meaning. It's just that you're just trying to figure out which one is in excess. And this would be 2 moles divided by 6. Okay, because the ratio is 6. So I think this would come out to be 1 by 3 or 0.33, and this one would come out to be 0.5. So this one is clearly the bigger, this number is clearly the bigger value. So that's the one that's in excess. So if I were to find AlCl3 moles, I'm going to use these moles, not those moles. Again, you can even confirm whether it's in excess or not. 6:1, so 2 moles would react with how much? 2 divided by 6 into 1. Use ratios, 6:1. So what do you get for this? Let me just open a 2 divided by 6 into 1. So it's going to be 0.33 moles. So you never needed 0.5 moles. That was the wrong quantity. Only 0.33 moles were needed in the reaction. So if I were to find AlCl3 moles, I'm going to use these moles. If I were to find H2 moles, I'm going to use these moles. So is this clear to everyone? Any questions about this? So is this clear? Mahad, Maz, Oswa, all clear?
Yes, sir. Clear.
Okay. So let's move on to past papers now. Okay. Remember, there's still stuff left in moles. But what we are going to do is we're going to do past papers topic wise. Okay. I mean moles subtopic wise. So we're going to start with the first one: moles, mass, and ratios. You don't get a lot of limiting and excess reactant questions a lot. But that's definitely a question that would come at times. So let's start with the first thing. Remember, every moles question, the equation is the most important thing. Without the equation, you can't really figure out. You won't be able to do much. Not even the equation. You need the ratio. You're more interested in the ratio, not just the equation. You need the ratio. So right now he's talking about thermal decomposition of calcium nitrate. We did decomposition reaction, so I'm going to quickly do that. Calcium nitrate is CaNO3 twice. And there's going to be thermal decomposition. A metal oxide, NO2 and O2 is produced. You should know how to balance this. You can remember all nitrates would decompose in this way. Group 1 nitrates are not in your syllabus. We're not going to talk about group 1 nitrates, but group 2 nitrates or any other nitrate that would decompose in this way. And this would be 2NO2 and this would be half O2. Now the question says that 4.1 grams is decomposing. So remember, the equation talks in moles. Find the moles. You're given the mass. So moles would be the moles of this thing would be 4.1 grams divided by the MR, which would be 40. Plus nitrogen is 14 plus 16 into 3, and that's twice. So that's 62 plus, I think that's 62 into 2, that's 124 plus 40, that's 164.5, 164.1, I think. Can anyone confirm? And remember, when you're doing MR calculations, just 1697 data booklet. So also remember, whenever you're doing MR questions, make sure you use the most accurate MR values. Okay, just don't use your memory that much, because I did previously tell you that the MR values are pretty accurate now. I mean, they're a lot more accurate compared to your O-levels pure table. So your calcium value is 40.1. It's not actually 40, it's 40.1. Nitrogen is still 14, but 14.0, and oxygen is 16.0. So make sure this one comes out to be 164.1. How many moles do we get for this? Anyone, what are we getting for this?
0.025.
Okay, so you're getting 0.025. 0.0 to 4.1. Is it exactly that? 4.1, just 1 second. 4.1 divided by 164.1. So that is coming out to be 0.0. And remember, how many significant figures? I told you it doesn't really matter in MCQs because I mean, they're not even looking for the working. But remember, the original value is 3 significant figures. So your answer cannot exceed that accuracy. So when you write this down, this would be 0.025, and this you have to add another 0. 3 significant figures. Okay, like if I round it off at the third one, at this point, this would turn into 250. Okay, because there's an 8 following that, so it would become 250. And the value has to be 3 significant figure accurate because the original value is 3 significant figure accurate. But anyways, he's asking what is the mass of the solid residue that's obtained after the decomposition. These two are gases. Hopefully everyone knows that NO2 and O2 are gases. So the only solid residue that's left is this one. So it's 1:1. So it's going to have the same moles. It's going to be 0.0250 as well. And you have to find the mass of this thing. To find mass, just multiply it by the MR, which is 40.1 plus 16. So I'm going to multiply this value. Make sure when you're doing calculations on your calculator, don't try to round off things. So I'm going to keep the most accurate value on my calculator because every time I round off things, I'm going to lose accuracy. So at least when you're writing, you can't, you can't write the whole thing. You have to round it off. When you're writing it on the paper, you're going to use a rounded value. But on your calculator, keep the most accurate value. So I'm going to multiply that by the MR, which would be 40.1 plus there's an oxygen as well, that's 16.0. So that's 16. And what do I get? I get 1.40 grams rounded to 3 significant figures, and that's going to be C. So that's the first question. Kind of an easy question. Is this clear? The first question. Yes or no? Is this clear, Sidra?
Yes.
Alicia, Ahmed, Asha. Next one. What's the next question about? You've got a combustion of fossil fuels is a major source of increasing atmospheric carbon dioxide with a consequential rise in global warming. And so remember, a lot of questions are kind of very simple. They're just very long stories associated with them. So significant contribution to carbon dioxide levels comes from the thermal decomposition. This is what's happening. Thermal decomposition of limestone. Does anyone know what limestone is? Anyone? You must have studied this in O-levels.
Calcium carbonate.
Okay, that is calcium carbonate. Remember the thermal decomposition of limestone, a carbonate would decompose to form an oxide plus carbon dioxide gas. Okay, all these equations are written in the board that we were using. So it's simple 1:1. Now we're saying that limestone decomposes. So cement works roast 1,000 million tons of limestone, and a further 200 million tons is roasted in kiln. So what's the total amount? That's 1,200 million tons, I think. I mean, that's the mass. So now, whenever you do a moles question, you do things in grams. You don't use tons. But I mean, the conversion would be kind of just tedious. It would take a lot of time. Like a ton is 1000 kg. Every kg has 1000 grams. A million is 10 power 6. So if you try to convert it into grams, that's going to take a lot of time. So the easy way is just ignore million tons. I mean, solve the question assuming that it's 1200 grams. That's it. I mean, we can add the tons at the end. I mean, that's just going to save us time. Like if this was a theory question, you would have to do all the conversion. You can't do this. Like in the most question, you can do shortcuts like this. Like 1200 million tons. Million is 10 power 6. Remember, a ton is 1000 kg. And every kg is 1000 grams. So it's going to be this thing. It's going to be a lot of zeros. I mean, that's the quantity in grams. So if this was a theory question, you would have to do all of this. You would have to convert the million tons into grams. So remember, a ton, I mean, if you can note this down, a ton is 10 power 6 grams. And a million is 10 power 6 as well. So 1000 into 10 power 6 into 10 power 6 again. But luckily, it's not a theory question. So I'm going to just I'm just going to ignore the conversion. I'm not going to do the conversion. I'm just going to use my shortcut. Just think of it as 1200 grams and just solve the question. He's asking, what is the total annual mass output of carbon dioxide? So we're looking at the mass of carbon dioxide. So I can find the moles of this. Moles would be mass divided by MR. So it's 40.1 plus 12 plus 16 to 3, and that would give me 100.1. So I can quickly find the moles. So that's going to be 1200. Divide that by, I think it's going to be 100.1. That's the MR. And I get 11.99 moles. I get 11.99 moles, rounded to 3 significant. Or is it just 11 point? No, 3 significant figures. So it's going to be 12 moles. I get around 12 moles for this. If I round it off at the third. So it's going to be 12.0 moles. So that's coming out to be just 1 second. So anyways, this comes out to be 12.0 moles, right? 1:1, so carbon dioxide moles would be exactly the same. That's going to be 12.0 moles. And you multiply it by the MR, you get the MR of carbon dioxide is 44. Carbon is 12, oxygen is 16. 16 times 2 is 32 plus 12, that's 44. So you multiply by MR, you get the mass. So we're going to do just that. Remember, on my calculator, I'm not going to round off things. I'm going to keep them as accurate as possible. So multiply it by 44. If I do that, I get this value. I get 527.47. So the answer is and rounded to 3 significant figures, because remember, my value cannot be more accurate than the values that I'm using. So 527, I mean, this gets rounded downwards. So it's going to remain 527. So the answer is going to be B. Right? The answer is going to be B. I said, just imagine if you had taken 12. Instead of using the most accurate value, if you had taken 12 times 44. If you had done that, the answer would have been 528. You're losing accuracy by just rounding off. So be very careful when you're writing things on paper, you round off things. But just don't do that on your calculator, because you lose accuracy. I mean, I got exactly 527 because I didn't round off things on my calculator. Writing stuff, you're going to round off things, okay? So is this clear, 527? Mask question?
Yes sir, ये 1200 कहाँ से?
1200 is given over here. Sorry, 1200 is this thing. So guy, he's roasting 1000 million tons and a further 200 million tons is roasted. So what's the total million tons roasted? 1200, right?
Oh yes.
तो cost नहीं है कि हम उसको मतलब grams में करें.
नहीं, इसमें grams में करने का फायदा कोई नहीं है, क्योंकि this is MCQs, right? So like if it was a theory question, you would have to convert that into grams. Okay, clear?
जी सर.
क्योंकि इसमें ना you can solve it using 1200 and whatever you get at the end, क्योंकि he's saying के quote the value in million tons. So I'm just going to write के I'm getting 527. I was getting 527 grams. ठीक है, I assumed it grams, but I'm just going to write it as 527 million tons. ठीक है, so for MCQs I can use this shortcut, but not for theory, because in theory they're looking for the working as well. So in theory you would have to do the whole conversion. ठीक है, but MCQs not required. So is this question clear?
Yes, sir.
So now I'm going to send this. Try and do the or we're going to go through. I mean, there are lots of topics. The first one, okay, just try and go through the first ones, okay. This would be the assignment for the whole week, so you can go it at your pace. We'll be doing this. Ye wala moles, mass, and ratios. I think that's just up till page 4. So tomorrow we'll one by one do each one of them, okay, and. So hopefully in approximately 2 weeks we'll be done with this worksheet. So let's continue tomorrow. I'll send you the worksheet on the group. Okay, everyone, take care.
Sir, I had a question.
Allah.
Sir, I had a question.
Yes.
सर मैं पूछ रही थी कि ये जो अभी आपने लिमिटिंग वाला करा है, मोल्स के मतलब 90% क्वेश्चन में हम यही कर सकते हैं ना कि लिमिटिंग और एक्सेस वाला.
नहीं किधर गया, एक सेकंड. नहीं, मोल्स के 90% क्वेश्चंस जो है they're not about limiting and excess. मतलब only
मतलब जो रेशियो लेकर फिर उनके मोल्स फाइंड करना, वो तो ज्यादातर लिमिटिंग और एक्सेस ही कर सकते हैं ना.
नहीं, इशू ये होता है कि मेजॉरिटी क्वेश्चंस में एक ही के मोल्स दिए होते हैं, तो वहां पे लिमिटिंग एक्सेस इज नॉट एन इशू. मतलब अगर लेट्स से मेजॉरिटी जो क्वेश्चंस होंगे दे वुड लुक लाइक दिस, जैसा अभी हमने नहीं किए. मेजॉरिटी क्वेश्चंस वुड बी के बस एक के मोल्स दिए हैं, दैट्स इट. बस उसके मोल्स यूज करो, इसके निकालो, इसके निकालो, ठीक है, रेशियो लगा के.
तो मतलब वैसे ही मतलब थोड़ा सा ही डिफरेंस, लेकिन उसी तरीके का ही है ये भी.
हाँ, ये एग्जैक्टली
मतलब-
मतलब लिमिटिंग एक्सेस वही है. लिमिटिंग एक्सेस में बस इशू ये होता है कि दे गिव यू मोल्स ऑफ टू थिंग्स. वन ऑफ देम इज
लिमिट
हाँ
लिमिट वाले से बाकी के मोल्स फाइंड करने होंगे.
हाँ, तो बस उसमें इशू ये होता है कि वन ऑफ देम इज द रॉन्ग वन. अब वो स्पॉट करना है कि कौन सा इनमें से गलत है, कि मतलब इफ आई वांट टू फाइंड द मोल्स ऑफ दिस एंड दिस, तो शुड आई यूज दिस या फिर इसके यूज करने ना. तो वहां पे जाके मसला आता है कि यूज किसके करें, कौन से वाले गलत है. तो अगर वो रेशियो मतलब वो जो मैंने तरीका बताया था 0.4 डिवाइड बाय 2, 0.5 डिवाइड बाय 1, तो ये वैल्यू बड़ी आ रही है, दैट्स द वन दैट्स इन एक्सेस. इसका मतलब इट्स नॉट फुली. तो जो भी कैलकुलेशन करनी है ना, वो इससे करनी है, नॉट दिस वन.
सर अगर एक दिया हो तो हमेशा एक वाले जो गिवन होगा उसी से हमने
हाँ, फिर तो चॉइस ही कोई नहीं है ना. फिर तो वो लिमिटिंग एक्सेस वाला इशू ही नहीं है ना. लिमिटिंग एक्सेस का सिर्फ मसला तब आता है कि जब दो रिएक्टेंट के मोल्स दिए हुए हैं, तब आपको you have to ensure कि भी इसके अगर if I want to find the moles of this one, should I use these moles or these moles? तो you never use the excess moles. That's the whole thing. ठीक है,
ठीक है, थैंक यू सर.
Okay, take care. Allah Hafiz.